Hello everyone, welcome back to Harshi. In today's video, we're going to understand the JIT compiler in .NET and how it actually helps in executing our code. In the previous session, we saw that our C# code is converted into intermediate language and then it is handled by the CLR. But the thing is, the system cannot understand intermediate language directly, right? So the question is, how does this IL become machine code so that the CPU can execute? That's exactly where the JIT compiler comes in. In this video, we'll understand how JIT works and how it converts intermediate language into machine code at runtime. Now, let's first understand what JIT compilation is. JIT stands for Just-in-Time Compiler. Now, if you remember, our code is converted into intermediate language, right? But the thing is, CPU cannot understand intermediate language directly. So, before the program runs, this IL code has to be converted into machine code. And that's where JIT comes in. What JIT does is it takes this IL code and converts it into machine code at runtime just before execution. That's why it is called just in time because the conversion happens exactly when it is needed. Now, let me explain one important difference here. In traditional compilation, the entire code is converted into machine code before the program even starts running. So everything is already prepared and the program executes. But in .NET, it works differently. Here, the program starts first and then it converts the only required part of the code into machine code while the program is running. So instead of compiling everything upfront, it compiles only what is needed and when it is needed. Okay, this makes the execution more efficient and avoids unnecessary work. Now, let's understand how JIT actually works step by step. When your program starts running, the first thing that happens is the CLR initializes the runtime environment. After that, the assembly which contains the IL code is loaded into the memory. Now, here is the important part which I have explained earlier also. JIT does not compile the entire program at once. Instead, it works method by method. So what happens is when a method is called for the first time, JIT will check has this method already been compiled or not. Okay. If it has not been compiled yet, then JIT converts the method's IL code into machine code and then it executes it. Okay. But if the method is already compiled, it will not compile it again. Means it will directly execute the existing machine code. So this avoid doing the same work multiple times. So what does this mean is JIT compilation happens only when required and only the methods that are actually used get compiled. So, if some part of your code is never used, it will not be compiled at all. Okay. So, because of this, the program runs faster since unnecessary compilation is avoided. And also, memory is used efficiently because only required code is stored. Correct. And overall, the execution becomes more optimized. So, this is how JIT works internally and helps. Now, let's look at the different types of JIT compilation in .NET. First is normal JIT, which is the default behavior. In this approach, methods are compiled only when they are called. So, nothing is compiled in advance. Only the required methods are converted into machine code during execution. Okay. So, this gives a good balance between performance and memory usage, which is why this is most commonly used approach. Okay. And the second type is pre-JIT. It's also known as engine or ready to run. Okay. Here, the code is compiled before the application starts running. So, when the program starts, the machine code is already available, which makes the startup faster. But there is, but there is a trade-off here. Since the compiled code is already stored, it takes up more disk space. Okay, so you get faster startup, but at the cost of increased storage. The third type is EconoJIT. This is the mainly used in systems. This is mainly used in systems where memory is limited. What it does is it removes compiled code from memory when it is no longer needed. So instead of keeping everything in memory, it keeps only what is required at that moment. So this helps in saving memory, especially in constant environment. So overall, JIT gives us flexibility, means depending on the situation, we can balance between performance, memory, and startup time. And now let's see why JIT is important. First, it helps with platform independence. So you write your code once and JIT will convert it into machine code based on the system where it is running. And that's why same application can run on different systems without any changes. Next one is runtime optimization. Since JIT compiles code while the program is running, it can adjust based on the system. Like depending on the processor or how program is used, it can make the code run more efficiently. Another important thing is selective compilation. JIT doesn't compile everything. Okay, it compiles only the method that are actually used. So, if some part of the code is never used, it simply won't be compiled at all. Okay, and finally, memory efficiency. Since everything is not compiled at once, memory is used in a better way. Means only required code is kept and unused code can be removed if needed. Okay, so overall, JIT helps in make JIT helps in making .NET application more flexible, efficient, and optimized at runtime. Okay, let's quickly go through the flow once again. When we write code, it is first converted into IL code during compilation. Okay, then the CLR loads that code and it will prepare an environment for execution. After that, what happens is JIT compiler converts IL code into machine code, but only when it is required. Okay, and finally, this machine code is executed by CPU and will get the output. So, this is how JIT compiler works internally. So, this is how JIT compiler works internally in .NET. It plays a very important role in making our code executable by converting intermediate language code into machine code. At the same time, it also helps in improving performance and maintaining platform independence. So, once you understand this, it becomes much more easier to see what's happening behind the scene when .NET application runs. Okay, I hope you understood JIT completely. And that's it for this video. I hope this made the concept of JIT clear and easy to understand. If you found this helpful, please don't forget to like and subscribe to Hershey Learn. Okay, I'll see you in the next video. Until then, keep learning and have a great day.